Audio Jungle. Audio Jungle.
So previous year gate question in turbo machine. If I say turbo machine, so we'll solve question from axial flow compressor. We'll solve question from centrifugal flow compressor. We'll solve question from axial flow turbine. Okay, so previous year gate question. Gate A. Okay, so now I have first question here. This is the problem number 1.
Yes, sir.
Problem 1. So this is the linked question. Okay, linked question means one question, one statement we have, and then back to back 2 questions will be there for 4 marks, 2 plus 2, 4 marks question. So the statement is, listen carefully. A multi-stage axial flow compressor. So I must say axial flow compressor, which is nothing but AFC. Okay, axial flow compressor means AFC. In short, I will write so we can save our time. Centrifugal compressor, I will say CFC, and this one I will say AFT, axial flow turbine. Okay, right. So a multi-stage AFC compressor. Okay, AFC operating at an adiabatic efficiency of 0.9 develops a total pressure ratio of 11. The total temperature at inlet to the compressor is 335 Kelvin, and the stagnation enthalpy rise across each stage is 37 kilojoule per kg, right? If gamma is 1.4 and specific at constant pressure, so I must write Cp, no? In short, Cp is equal to 1.006 kilojoule per kg Kelvin. Okay. Then the first question, this is the question, actually this is the one statement basically they have given to us, and based on this statement we will have a question. All right, so in the statement we can see all the data, required data they have given. Okay, and need to remember the axial flow compressor, that velocity triangle and that formula. That is more than enough. Okay, that is more than enough. And here if you check for this very simple, they have mentioned the adiabatic efficiency is what, 0.9, here it is given. Okay, and total pressure ratio means RP they have given 11. The total temperature at the inlet to the compressor 335 they have given, and the stagnation enthalpy rise across the stage, remember this is across the stage, it is given 37 kilojoule per kg. Gamma is 1.4 and Cp 1.006 kilojoule per kg. If they have given, you have to take that value. If they have not given, whatever required data for the problem, you can assume that. Now the problem number one is, you can say A, and this is nothing but the total temperature rise. Rise across the compressor. This is the question. Okay, option they have given 310.1 Kelvin, option B 366.3 Kelvin, option C 392.1 Kelvin, option D 405.4 Kelvin. So this is the problem number one. So first we will try to solve this problem one. Okay, now all right, so okay, so in this case, see the total, if they are asking the total temperature rise across the compressor, so first of all, as per the given data, we need to check. See, for the total temperature rise across the compressor they are asking, so here we have a compressor. Okay, this is what compressor. So for this compressor, if you can select numbering as per your requirement, because the efficiency they have given, so definitely you need to apply efficiency of the compressor across the compressor, you have to apply, because the efficiency they have given for the compressor. So better if you choose the a numbering system here. Okay, now I will take this as a TS plot, or in the same way we can draw the HS plot also. This is TS plot. Okay, if you remember, I think in the compressor when I taught, I had taken the points, and that points across the compressor was 1 to 3. Yeah, it was 1, 3. So I will write the point, 2 points we have. Okay, this is 1 and this is 3. So if you check the compressor, so compressor will be compressed the air like this. This is what, not 1, and this is what, not 3, and this is a not 3 dash. So this is the 1 and this is the 3 for the compressor. Okay, if you remember the formula of the enthalpy, that formula of the efficiency, so what is the formula of the compressor? adiabatic efficiency they have given. If there is no loss, you can consider its isentropic efficiency, right? So what will be the isentropic efficiency from this formula? It is the isentropic enthalpy rise divided by the actual enthalpy rise. So what is the isentropic enthalpy rise here? You can say isentropic. So isentropic will be H03. Check the formula, it is given in your notes. H03 dash minus H01 divided by actual enthalpy rise H03 minus H01. This formula already you know, it is well known, right? Now the same formula you can write in terms of temperature also. So I had given that formula in the temperature also. So Cp T03 dash minus Cp T01. So if Cp in numerator and denominator you will cancel. So what you will get, T03 dash minus T01 divided by T03 minus T0. If you remember, this was the formula, right? And if you remember this T03 minus T01, I told you this is the temperature rise. This is the temperature rise, and this temperature rise is the T03 minus T01. This is the temperature rise, basically the overall temperature rise, okay? Now, so because why I am saying overall, because the stage, across the stage value they have given to you. If you check here, across the stage they have given, right? This is the enthalpy across the stage. So if you are writing the efficiency, this efficiency, because this formula you are writing adiabatic efficiency. So if you are writing this efficiency, so this efficiency they have given for the multi-stage AFC, means this efficiency is for the complete system. I mean, it is not for the one stage or two stage, it is for the complete system. It means it is the efficiency of the compressor. So if you are writing this efficiency, so definitely this efficiency here, that this T03 minus T01, whatever the temperature you are going to write, it is the overall temperature. It is the overall temperature. Okay, there should not be any confusion about it. Now this value will be T01. If you take common here, T01, so what you will get, T03 dash minus T01 minus 1 divided by delta T not overall. Agree? Now this is nothing but T01 in bracket. This is what? It is the RP, and this is formula. If you apply gamma minus 1 by gamma 1. Check the formula I had given, okay? It's not new formula, it is already given to you overall. Now here we'll keep all the data. So what we'll get? See, if you check adiabatic efficiency, they have given to us. They have given RP also, the pressure ratio here it is given. See, RP value they have given to us. Check this value, RP. Here, this is the total pressure ratio for the multi-stage. So RP, this is RP value. Okay, and the temperature T01. The total temperature. See, the total temperature at the inlet of the compressor. So this is what, 3 T01. This is the T01. So all the data you have, and efficiency they have given 0.9. So what you can calculate here, the total temperature rise you can calculate. So the total temperature rise, if I will write for this, so this total temperature rise is nothing but delta T not overall. If you write this value, so this is nothing but T01 by eta IC in bracket RP to power gamma minus 1 by gamma minus 1. If you check T01, it is given, I think, 335. So if you keep all the data here, 335 divided by what is the efficiency? Efficiency they have given 0.9 in bracket RP is 11 to whole power of this. What is the gamma minus 1? Gamma is, they have given to us, it is 1.4. So gamma minus 1, 1.4 minus 1 divided by 1.4 and minus 1, the whole bracket. So if you calculate this value, so you will get delta T naught. Okay, so this delta T naught you need to calculate, delta T naught overall. If I say overall, that means it is for the complete system. Check it. Check from the same statement. We have another question. and it's simple one. What is the question? The question is problem B. The question for the same statement we have the total temperature, total number of stages required. Very good. So the total number of stages required. This is the next question required R. This is also for 2 marks. This was for the 4 marks question. Now how to get the number of stages? Very simple. In the system across the across this compressor, that end to end, okay, that end to end you have calculated total temperature delta T naught overall. All right, end to end you have calculated. You can say this is the compressor. Anyway, okay. Now in this we have many number of stages. All right, we have many number of stages. We have many number of stages. All right, so we have many number of stages, we don't know. So for one stage, if the value we have for one stage, so total number of stages you can calculate. So what is the number of stages formula? Number of stages is equal to, what would be the formula? Simple mathematics only. So total number of stages will be the total temperature rise across compressor divided by temperature rise across one stage. Okay, so this can be in terms of enthalpy also. You can write delta T, delta H naught, also you can write overall divided by delta H naught for the one stage. The same formula you can write. So if check, if number of stages you want to find, then what you will do? Simple. So if number of stages if you want to write, then you will have here n is equal to delta T naught overall delta T naught stage, or you can write delta H naught overall divided by delta H naught stage. So if you check delta H naught stage, they have given to us delta H naught stage they have given to us in the problem. What value they have given? 37 kilojoule per kg. So what will be the delta H naught overall? You know, it is Cp delta T naught overall. We can get this Cp they have given to us in the problem. How much it is? 1.006 kilojoules, so 10 to the power 3 into, okay, into delta T naught overall. So if you calculate this value, so here 366.26, it's a 366.26. So 366 point, if you calculate this value, so you will get delta H naught overall. If you do, where is my calculator? Here. If you do this, so how much you will get? 1.006 into 366.66. you will have 368.85 kilojoule per kg. You can use this formula now, and if you use this formula, then you will get how much? You will get N is equal to overall value you got 368.85 kilojoule per kg divided by stage wise it is given 37. So if you solve this kilojoule per kg, so if you solve divided by 37, so you will get 9.96. You will get 9.96. Check n number of stages. So 9.96, but it's a common, no? Common sense you have to use. Fraction is not possible. Number of stages, how fraction will be possible? Not possible. So you have to write round off. So if you write round off 9.96, round off is what? 10. So how many number of stages we will have? It is 10. Now if you check the option, so option I had not written here in the problem, I think. Option they had given, I will write now. Option they had given 9. Option B it was given 10. Option C is it was given 11. Option D it was given 12. So your correct answer is C. If single mistake if you do, even though little bit, so immediately your answer will vary, no? So 9, 10, 11, 12, it's like the number. So 9.96 you got. So don't take 9. 9.96 approximation is what? 10. Alright. Always remember. So this is also for the 2 marks. So 2 plus 2, 4 marks question. So the next question, it is next problem. Problem 2, and it's again it is for 2 marks. Okay. 2 marks question, and this question is what asked in GATE. This is asked in GATE 2010, sorry. Okay, 2010. Now see this question. It is given the inlet stagnation temperature for a single stage AFC axial flow compressor is 300 Kelvin, and the stage efficiency, here it is clearly mentioned, it is stage efficiency 0.80. Okay. Following conditions exist at the mean radius of the rotor blade. If you remember, when I explained the velocity triangle, that time I told you whatever the velocity triangle we had drawn for the axial flow compressor, for the centrifugal compressor, for the axial flow turbine, it is for the mean radius, average. Okay. Now data they have given to us, blade speed. They have given blade speed 200 meter per second. Axial flow velocity. Axial flow velocity is 160 meter per second. Inlet blade angle, it is mentioned beta 1. Beta 1 they have given 44 degree. Beta 2 they have given 14 degree. Gamma they have given 1.4 and Cp they have given 1004 joule per kg Kelvin. Okay, what is the question? The question is, what is the stagnation pressure? What is the stagnation pressure ratio for this compressor? This is the question. If you see the options are 1.41, option B 1.37, option C 1.51, option D we have 1.23. Very simple, very basic question, axial flow compression. So how you will able to solve this problem? If you know the velocity triangle, because alpha 1, beta 1, I mean beta 1, beta 2 they have given to us. So if you know, then definitely you will able to solve. Otherwise, one more thing, I had given pressure ratio in stage, that formula, so I am not going to write here each and every steps because it is not required. Only I will draw the velocity triangle and I will write the formula because derivation already done, so I don't want to waste my time. Only velocity triangle I will draw. Even velocity triangle is also not required, but just for your practice only, I must say you draw multiple times that velocity triangle. Okay, if you draw velocity triangle, you will be confident. So draw the velocity triangle only. This is rotor. All right. This is omega 2. This is omega 1. This is C1. Okay. WT1, CT1, whole is U. Similarly, this is WT2, this is CTT2, this is C2, alpha 2, beta 2, alpha 1, beta 1. So this is the velocity triangle. Why I am saying to draw velocity triangle? Because you should be in practice. Okay. Anyway, now if you remember, check in your notes, I had given the formula and it was derived also. It was derived formula and that was pressure ratio in stage. It was derived. It is not given directly, it was derived. If you check my previous lecture, you will get pressure ratio in stage. So what is the formula for the stage? Check, and what formula I had given? It was, just recall it now, P03 by P01. And it was RP. RP is the pressure ratio. Okay, stagnation pressure ratio. And what was the formula? If you remember, the formula was 1 plus, it was eta of the stage, means stage efficiency, into delta T naught. This was the stage temperature rise, okay, divided by T naught 1, okay, and the whole bracket was gamma upon gamma minus 1. Just recall it. I had given this. Now this RP will be, now I can write in terms of beta 1, beta 2. So 1 plus in the formula I had given in terms of beta 1 beta 2 also at the same time. It is u ca. What is the delta T naught? I am just writing stage na, tan beta 1 minus tan beta 2, okay, divided by Cp divided by T naught 1, and this is the whole power. Okay, if you want, just for your practice only, you just remove this, not required. You can write Cp here also. In derivation I have given the derivation, you can understand easily now where Cp and how that Cp came. Okay, so check your derivation. So this will be now Cp T naught 1. Now each and every value you have, you can get that. Each and every value 1 plus eta stays. See in the problem itself, everything they have given. They have given eta stays. How much? This is the eta stays. See here, this is the eta stays. Okay. Inlet stagnation temperature. This is what T naught 1. And this is what blade speed u, this is what axial speed ca, beta 1 beta 2 you have, gamma, everything you have. You just keep the value and you will get your answer. So 1 plus that value here, it is nothing but 0.8, 1 plus 0.8 into u is nothing but 200 into ca is nothing but 160 into tan beta 1 is nothing but 44 minus tan beta 2 is 14. Okay, take this small bracket, actually it's divided by Cp, it is given 1005. T naught 1, it is in the problem itself, it is 300. The big bracket you will have here, and it is gamma upon gamma minus 1. Gamma is given 1.4 divided by 1.4 minus 1. So if you solve this, you will get your answer. Here the value you are getting 1.23. 1.23 you are getting, okay, after calculation. Check the option which one is given. So 1.23, this BD is the correct answer. Okay, this is the answer. So this was asked in GATE 2010. Okay, and it was for 2 marks. So you can check. Simple problem they had asked only. If you know the formula, okay, if you know this formula, and obviously this was derived in my lecture, previous lecture. If you check, you will get the derivation. This is the pressure ratio in stage. So this formula you need to remember ultimate. Okay, derivation I have given. One time you have to derive it and then mug up the formula. If you do that, then very easy. Okay, very easy. Simple formula based problem. All right, so option is D. Okay, now we'll go for the next question. Now this question is obviously, it is also GATE question. So this is the problem 3. This is GATE AE problems. I will check in which year it is asked, but it is the GATE AE problem, and it was asked for 2 marks. Okay, so question is, in a 50% reaction, axial compressor stays, the local blade velocity is, local blade velocity is 300 meter per second. 300 meter per second, and the axial component of velocity is axial component of velocity is 100 meter per second. Okay, if the absolute inlet flow angle, if the absolute inlet flow angle alpha 1 is 45 degree, okay, the work per unit mass, the work per unit mass done on the fluid by the stays in, and it should be in kilojoule per kg is option they have given to us. They have given option A 30 kilojoule per kg, option B 40 kilojoule per kg, option C 50 kilojoule per kg, option D it's 60 kilojoule per kg. Unit is already written here, no? So no need to write, we just write 60 kilojoule per kg. Okay, so we'll solve this. Again we need to draw for the axial compressor, we need to draw the velocity triangle. Okay, and then definitely with the help of velocity triangle we'll able to solve this problem. So now going to draw the velocity triangle. Check carefully. Okay, this is beta 1, this is alpha 1, this is C1, this is omega 1, this is the rotor, this is what C2, omega 2, this is B2, alpha 2, CT2, omega T2, omega T1, CT1, right? Check in the problem what they have given nicely. They have given a blade velocity. What is the blade velocity? I told you many times, it is sometimes called blade velocity or blade speed or rotational speed. So all the wording what they are using in exam I have given to you. Okay, check my previous lecture, you will get. Axial velocity is given 100 meter per second. All right, if the absolute inlet flow angle alpha 1 they have given how much? 45 degree. This alpha 1 is given. The work per unit mass done on the fluid by the stays in kilojoules. So basically they are asking the work. So if you check the formula of the work, okay, first the formula is what given in terms of the alpha 1, beta 1, alpha 2, beta 2. One more condition they have given, R is given how much? 50% degree of reaction. No? 50% degree of reaction, here it is clearly mentioned. No? 50% in 50% reaction. So they have not written full word degree of reaction, but 50% reaction means it's a degree of reaction. So if we have 50% degree of reaction, then what is the mean of it? You should know that, okay? Because that is the mean one thing which is the clue for you to how to solve the problem. That is the one clue for you to start the problem, like how to do it, okay? So what is the clue for the 50% of reaction? R is what? If suppose 1 by 2, or it is also called 50%. If it is given, then it means alpha 1 is equal to beta 2 and beta 1 is equal to alpha 2. This is the mean of it, right? This is the mean of it. That already we had discussed. So now for this, how to solve this problem? Simple. Because if you check here, they have given CA, they have given to us, U they have given to us, alpha they have given. So alpha is what given 45 degree. You can say this alpha 1 is also beta 2, okay? That also beta 2, right? And if you remember the formula for the work, okay? So what was the work formula? Next I will solve this. So work done in terms of velocity, so it is UCA, because U is given, CA is given, so better I will use this formula. So it is UCA and it is tan beta 1 minus tan beta 2. This is the formula, right? This is the formula, okay? Or you can write this work in terms of the alpha also. So in terms of alpha, what is the formula? It is the UCA tan alpha 2 minus tan alpha 1. Alright, this is the formula. Now based on this, we have to solve this problem. What we will do? So if you want to use this formula, so beta 2 you have, but beta 1 you need to calculate. How to get beta 1? So that will be from inlet triangle. See, this is what? Inlet triangle. So if you check the inlet triangle, so from the inlet triangle you can get beta 1, because once you get beta 1, then your problem will be solved. So I will draw this triangle here once more. This is what? Inlet triangle, no? Not exactly like this, because here it is like isosceles triangle. Let me correct, no? Otherwise there will be confusion. So check the inlet triangle. It will be somewhat like no, fine. So this is what beta 1 and this is what alpha 1. Here this is what CA, this is C1, this is CT1, this is WT1, and this is what U. This is the whole information and this is the W1. Check, can we get this beta 1? If you write beta 1 formula here, tan beta 1 or sine cos, whatever you can apply, it simple trigonometric only, simple trigonometry. So this length should be known. Here you can write this U minus WT1, U minus CT1 will be WT1, right? So if you check this length, it will be U minus CT1, right? Now, so we can write here tan beta 1 is U minus CT1 divided by CA. And how to get CT1? Simple. Tan alpha 1 is CT1 divided by CA. So CT1 is nothing but CA tan alpha 1. Okay, so CA and tan alpha. What is the alpha? You can check here. It is given. No? Alpha is 45 degree. So tan 45 is what? It's a 1. So it's tan 45 is what 1? So it is CA. CT1 is nothing but CA. So now you can write tan beta 1. Tan beta 1 is U. U they have given to us. Check what is the value of U. Value of U directly I can put here 300 and CA is 100. So it is U which is nothing but 300 minus CT1 which is CA, and CA is 100 divided by CA is 100. So this value you can get. Okay, so you will get beta 1 here, and that beta 1 what I am getting here, it's a 63. What I am getting, I am just saying 63 degree. Okay, now your problem is what almost solved. Now here you can keep this value. So what is W? W is nothing but UCA tan beta 1. See here work done factor they have not given. If they have given to you, you need to use that. U is what 300, CA is what 100 in bracket. Tan beta 1 just now you have calculated, it is 63.43. Tan beta 2 is what 45 degree. You just solve it, you will get. So now I can write tan this minus tan 45 is what 1. So 2 minus 1 1 and 300. So it's 300 into 100 into 1. How much? 30 into 10 power 3. It is nothing but 30 kilojoule per kg. I told you when I derived this work, I told you that time it is the specific work. So 30 kilojoule per kg. So this is the answer. Check option. No? So in this problem you can finish in 2-3 minutes because I am solving and I am writing each and every steps, but in examination it is not required. Okay, you need to direct within 4-5 lines you can finish the problem. So this is the answer. So option A is correct. Alright, always remember, and it's a very simple problem. Okay, very simple problem, and just think it was for 2 marks. Okay, it was for 2 marks, and it was GATE, I think it was GATE 2010 or 13, GATE 2013. This was the GATE 2013. Okay,
Sir,
if you solve previous, okay, if you have question like absolute inlet flow angle alpha 1 is 45. So in this terminology, like if this terminology came and suppose alpha 1 they have not given and they have said absolute inlet flow angle is 45, then what will be the angle alpha 1, alpha 2, beta 1, beta 2? So very simple, absolute inlet. So I said the alpha angle is the, first of all it's a flow angle. So by that word you can understand inlet flow angle is, it means alpha 1. Otherwise if you are going to absolute, so I told you that time also to all, like alpha and beta. Beta is the angle which is making which is the angle between relative velocity from axial direction, and alpha is the angle which is making between absolute velocity and axial. Beta is the angle between relative velocity and axial direction, and alpha is the angle between absolute velocity and axial direction. So absolute meaning also you can understand. Okay, absolute inlet, it means they are talking for the C1 because absolute velocity is the C1 and inlet, hence it is C1. Clear? Okay, and that's the reason it is alpha 1. Done?
yes sir, got it.
Right. Now so this problem is what asked for 2 marks, and here I have taken more than 10 minutes I think for this problem, because I have drawn each and everything, given data I have written, but in examination you will have max to max 3 to 4 minutes for this problem, okay? And it's very simple. Directly you need to draw velocity triangle, okay, quickly, and from the velocity triangle check what they have given to you and what you need to calculate, and not write each and every steps not required. Few things you have to go by the short way, and directly you go and put in calculator and you will get your answer, okay? So that's the way to finish this type of problem, because problem will be easy but it will be lengthy sometimes. So don't waste your time like writing this formula many times I have written this formula, not required. In examination one time you write formula, draw velocity triangle, check what data they have given, and few things directly you need to calculate, and then you get the answer. And if it is MCQ, you mark it. If it is fill in the blank sometimes, so you check the unit properly, okay? And based on the unit, you have to fill that data if it is fill in the blank problems. So fine. Now we'll go for the next question, and this is from the axial flow turbine. So the question is a 50%. This is also get a problem, and it was asked for 2 marks. Okay, so a 50% degree of reaction and degree of reaction. Okay, axial flow turbine AFT operates with a mean blade speed of 180 meter per second. The flow leaves the stator and enters the rotor at an angle of 60 degree to the axial direction. So last lecture I had explained AFT, axial flow turbine. So based on that, 2 marks question it is asked, okay? To the axial direction, the axial velocity is 150 meter per second, okay, and remains constant throughout the stage, and remains constant throughout the stage. All right, the turbine power per unit mass flow, turbine power per unit mass flow is. So actually they are asking the specific work. So option they have given to us. What is the option for this problem? Option they have given us, option A is 29.76 kilojoule per kg. Option B is 41.12 kilojoule per kg. Option C we have 58.33 kilojoule per kg. Option D we have 61.13 kilojoule per kg. Very simple problem. What you have to do, simple I had explained the velocity triangle. Based on if you see the data, if you check axial velocity they have given to us here, they have set the angle also from enters the rotor of an angle of 60 degree, no, to the axial direction, and they have 50% degree of rotation they have given, and mean blade speed is also, so it is u, and axial velocity is what, ca. Okay, if you check the problem here, if you check the problem you will get it now. And they have given the angle also, and what is that angle? If you check what is that angle, they have said it is entering to the rotors. So what if any angle it is given with the rotor, so rotor angle from the axial direction they have given. So from the axial direction, if rotor angle they have given to us, so we will draw the velocity triangle and then we'll check what angle they have given to us. So this type of question, don't write the data blindly. If this velocity angle and all those things they have given to you, so first of all you will draw the velocity triangle. From the velocity triangle automatically you will get it. So this is the axial flow turbine, and for the axial flow turbine I had explained the velocity triangle. So this was the velocity triangle. Okay, this is the all right. This value is here, it is start from here, it is C1, and this was the obviously alpha 1, and this will be the CA, but this is what, nozzle or stator you can say. Okay, and then this flow will be obviously absolute velocity C2, and from the axial I told you this angle will be what, alpha 2, and this will be the relative velocity omega 2. So this angle only, this will be beta 2. all right, here this will be WT2. okay, and here this angle will be U, and the whole will be CT2. okay, anyway, and again we have rotor. So this is the inlet triangle. Now we have rotor here, so this is the rotor. So rotor will get velocity, and that velocity will be rotor velocity here, relative velocity, and from the rotor again the relative velocity will go from outside, and it will be like this. So this will be what, omega 3 relative velocity, and this will be obviously axial velocity which is constant throughout, and this will be what, absolute velocity C3. So from the axial this angle will be alpha 3, and this whole angle will be the beta 3. I told you relative velocity from axial will be beta, and absolute velocity from axial will be alpha. So numbering you need to take care. This is 2, this is from here, this is 1, this is 2, and again one more blade came, so after this 3. Alright, now check, they have mentioned R is what, 50% degree of reaction they have given to us. So for the rotor 50% degree of reaction they have given to us. So you just forget about this, this is not for our use. Okay, inlet triangle, this is inlet triangle, and this is the exit triangle, and where is the rotor, this is what, rotor. So across rotor what is the inlet and exit we have to check. So it is 2 and 3. So for 50% degree of reaction I explained you it is 2 and 3. So that means alpha 2 will be beta 3 and beta 2 will be alpha 3. That's the mean of it. Number 1. Number 2, if you read the statement what they have said in the problem, let go back and we need to check what they have given to us. They said the flow leaves the stator, okay, and enters the rotor of an angle of 60 degree. So it is leaving from the stator. It is leaving from the stator means, see, this is the stator, it is leaving from stator, and it is entering to the rotor. In the problem itself you read it and you will understand. Okay, and stator and enters the rotor at an angle of 60 degree to the axial direction. So from the axial direction, that angle will be 60. Let us check. So entering to the rotor here, sorry, go forward. So from the axial, this is the what axial point, check. This is from axial and it is entering to the rotor. So from the axial, this is the axial only. So from axial, now this axial and it is entering to the rotor, they said. So actually they have given omega 2 velocity and omega 2 will making angle beta 2. So basically whatever the angle they have given to us, it's a, check in the problem, it's a beta 2. Okay. So here now coming to this point, check. The flow leaves the stator and enters the rotor. Okay. Rotor of an angle of 60 degree to the axial direction. The axial velocity is 150 degree, remains constant throughout the stage. The turbine power per unit mass flow is. One more point you need to take care. See, they have clearly mentioned the flow leaves the stator and enters the rotor of an angle 60 degree to the axial direction. Here the angle they have given 60. If you check in this case, to the axial it's okay. See, in this problem you read it, to the axial, from the axial this angle will be what, beta 2, which is entering to the rotors, but at the same time the stator will be leaving the velocity, and that velocity will not be relative velocity, it will be the absolute velocity. So basically they are talking about the alpha 2, because from the axial this flow is what coming from the rotor, and it is entering to the rotor. Obviously rotor velocity will be relative velocity, but the leaving velocity from the stator is what, C2. One way to understand this angle. Other way, if you check, beta 2 will be less than alpha 2, and the angle what they have given 60 degree. Again, if in the statement suppose you have doubt, and if you check the angle, if they have given angle 25, so this 25 you can consider, okay, it is possible 25 angle will be beta 2, because beta 2, but 60 they have given to you. So it's very sure that 60, which is the highest angle from the axial, and highest angle from the axial will be alpha 2, not beta 2. In this way also you can understand, because in statement sometimes you may get confused. Like here already after reading the statement, it was seeming like, okay, it is given beta 2, but if you check the value of angle which is given 60 degree, so 60 degree beta 2 cannot be possible. If you check, beta 2 will be less than 2 alpha 2. Okay, so actually it is given alpha 2, and in this statement also, now if you read, then you will understand that flow is what leaving from the stator. So what is the velocity leaving from the stator? It's the absolute velocity actually, C2, and from axial C2 angle they have given to us, so it is alpha 2. Alpha 2 they have given to us 60 degree, right? Now we'll solve this problem. If you check what is the work formula, so work is nothing but, in the turbine it is UCA tan alpha 2 plus tan alpha 3, or you can say it is nothing but UCA tan beta 2 plus tan beta 3. This is the formula. Okay, check alpha 2 for the 50% degree of reaction is nothing but beta 3. So again here beta 2 is unknown. If you take alpha 2, then alpha 3 will be unknown. So how to get this angle? So it's a simple only. If you want to calculate that angle of beta 2, okay, so or even alpha 2 is given, alpha 3 if you want to calculate, so it's your choice what angle, what formula if you want to use. Suppose beta 2 and beta 3 formula we are going to use, so beta 2 need to calculate. So what you will do, so how many degree of reaction formula we have? We have 3 degree of reaction. Okay, so if you want to calculate here in this formula, suppose alpha 3 if you want to calculate, then degree of reaction formula in terms of alpha 2 and alpha 3 I will write here, and then you calculate that value of degree of reaction. See, this is the degree of reaction formula. What we have, if you check in terms of this alpha 2 and alpha 3, we have 1 minus Ca by 2u tan alpha 2 plus tan alpha 3. So what is the degree of reaction? They have given 1 by 2, 1 minus Ca they have given to us. What is the value of Ca? Check axial velocity they have given to us, and it is nothing but axial velocity 150 and speed is u 180. So 150 and 180 they have given. So 152 into 180 in bracket, tan alpha 2 they have given to us 60 plus tan alpha 3. So we'll calculate tan alpha 3 and then we'll get alpha 3 from here. Here I got it's nearby 0.53204 this value. So if you take inverse of it, so it's like 28, approximate to 28 degree. Okay, this is the alpha 3. Now in the formula, work done formula, you can write W U Ca in bracket tan alpha 2 plus tan alpha 3. So U is nothing but 180, Ca is 150, tan alpha 2 is 60 plus, just now you have calculated alpha 3, what I got 28. So this is W, which is the specific work. If you do it, then the approximate value of tan point is plus tan of 60 into 180 into 150. It's what I'm getting here, it's a 61130.59. It's a joule per kg. Now if you calculate this value, divide by 1000, so it's a 61.13 kilojoule per kg. Check any option if it is given 61. Approximate, no? This value if you check here, 61, sorry, 61. What here approximate this value nearby this value. So what is the correct option?
Sir, I had one doubt about angle.
Yes, I will tell you.
So here, flow leave the stator and then enter the rotor. So the angle should be beta 2.
No. That's the reason. Actually, the flow leaves the stator and enters the rotor.
And
Of an angle of 60 degree. Correct. And to the axial direction. In the statement they have given to the axial direction. So see, it seems like it's a beta 2. That's the reason I told you, because here they have not mentioned it is alpha 1, alpha 2. They have simply given angle. So for sometimes they give the statement so that you can confuse. Like in first attempt, even I thought this is beta 2. But if you check what they said, the flow leaves the stator. The flow leaves the stator and leaves the stator. So what velocity component which is leaving the stator? It's the absolute velocity, and then absolute velocity will have a two component. That will be relative and obviously blade speed. Yes or no?
Yes,
so
yes.
So leaving velocity will be C2, and again this C2 will have a two component which is nothing but relative velocity and blade speed U. C vector if you write, then it will be U plus W. Yes or no?
Yes, sir.
So it means they are talking about the C2 velocity, and C2 is making angle from the axial is alpha 2. Number one, from this you can understand. Second way, if you think about beta 2, then what will happen? Actually beta 2, even the by triangle you can see, and by the magnitude of the velocity component also, relative velocity will be lesser than absolute velocity. Hence relative angle, which is nothing but blade angle, will also be less than alpha 2. So beta 2 is what? Less than alpha 2. So beta 2 value or magnitude will not be 60 degree. If beta 2 is 60 degree, then you can think alpha 2 will be 80 degree or more than 60, which is practically not possible. Beta 2 will be max to max 25, 30, 35. More possibility is 40,
less than 30 degree.
yes, but not more than that. Okay, so in this way also you can recognize, because it happens many times they will give the statement, so you need to take care of it about the angle. For that reason I'm saying, every time for any problem it came, immediately you draw the velocity triangle, and with the velocity triangle, you just like in compressor I had given velocity variation, similarly in turbine also we have a velocity variation. Okay, if you check before entering to the rotor, relative velocity will be less in turbine, but once the flow is passing over the rotor, then relative velocity will be basically increasing. Okay, it will be increasing. Why? Because that flow will hit to the turbine blades, and then it will start rotating, right? So if it start rotating, so initially the flow rotor was a stationary condition, you can think, and the flow is coming with very high speed. So, and after hitting, then only it will start rotating. Okay, so when the rotor was stationary and flow is with coming with very high speed, so that time relative velocity will be very high. It will be very high actually. And so before rotor that relative velocity will be less, but after rotor relative velocity will be increased. Similarly, absolute velocity before rotor entering to the entering to the rotor, absolute velocity will be high, but once it will pass over the rotor blade, then absolute velocity will be decreasing. Actually that kinetic energy will be decreasing because it is hitting to the rotor, so the energy will be absorbed to the rotor, you can say, and absorbed in the sense it will be used to work the rotor, and then only turbine will start rotating. So here what happening, that fluid is working on rotor. In compressor what happening, in compressor that rotor blade was doing work over the fluids, but here fluid is doing over the rotor. That's the only difference. So for that reason only absolute velocity will be decreasing after passing the rotor blades here in turbine, but in compressor it was increasing. Here it is decreasing. Check the absolute velocity. If you compare the C3 and C2, if you compare the C3 and C2, so C3 will be less than C2. Okay, C2 will be higher, and if you compare the relative velocity, so omega 3 will be greater than omega 2, relative velocity will be increasing, but in compressor it is just opposite. You can check now and you can compare that. Both things is just opposite in compressor and turbine. So for that reason, if you solve the problem, so as well as if they have not given alpha 2, alpha 3, beta 2, beta 3, if they will give the statement, so keep your concentration over the statement, and whatever data they have given, you check it is beta 2 or alpha 2, because sometimes with the statement you may get confused. So that time this velocity triangle will help you out. Hope this one is clear to everybody.
Yes sir, clear.
Done.